So we're doing reference angles once more, and this time we're going to be doing it in radians. So it's going to feel a lot different. All right, so I've still got all of our little formulas here. Take this off. All right, got all of our formulas here. If it is in quadrant 2, instead of it being 180 minus the angle, it's going to be pi minus the angle. All right, instead of it being in quadrant 4, instead of it being 360 minus the angle, we're going to be doing 2 pi minus the angle. So everything's the same, except everything's been converted to radians here. Now I want to say one way that you could do these that's kind of cumbersome is, instead of dealing with radians, you could convert everything to degrees, if that makes more sense, and then find the reference angle and then convert that back to radians. So you can do that. It just takes, I don't know, it's kind of cumbersome, kind of trouble. All right, so question is, what is the reference angle for 5 pi over 3? Now, part of the trouble with radians is we don't have that mental map of where things are, what quadrant it is. But thankfully, 5 pi over 3 is one of our special angles, so right here. So we know it's in quadrant 4, which means we know we could use this formula, 2 pi minus theta, to figure out that reference angle. Let's go ahead and we'll work it out that way, and then I'll show you, another way that we could have done that. So 2 pi minus theta. Oh, sorry. 2 pi minus the actual angle that we're messing with. 5 pi minus 3. Well, what we want to do is convert 2 pi so that it has a denominator of 3. All right, so this is the same as, if we multiply this by 3 over 3, we'll get 6 pi over 3, which is 2 pi still, minus 5 pi over 3. Subtract these, you'll just end up with 1 pi over 3, and that is our reference angle. All right, so instead of our reference angles being between 0 and 90, they're now actually going to be between 0 and pi over 2. So when you're looking at this 5 pi over 3 angle here, the reference angle is this angle between, where it terminates and the x-axis. So I think on this one, so in this case it was pi over 3, but for this one I think it would have been easier if we were just to, look at the picture here and just calculate this angle, using common sense, I guess. If every chunk here, every chunk of the pi is pi over 6, and every 2 chunks right here is pi over 3, well, we could have figured out that the 2 chunks that we were missing is pi over 3 that way. I think that would have been a little easier for us. But you can't always do that, but in this case you could. All right. Next one here, we got to find the reference angle for negative 5 pi over 3. First thing we want to do is find its coterminal angle. So we're going to add 2 pi to this so that we bring it between 0 and 2 pi, or 0 and 360. The denominator is 3, so we got to multiply by 3 over 3 again. And it's actually going to be 6 pi over 3. All right. So when we add 2 pi, we're really just adding 6 pi over 3. Negative 5 plus 6. That gives us 1 pi again over 3. And that is in the first quadrant. So this is our coterminal angle, pi over 3. And because it's in the first quadrant, it is itself the reference angle. All right. That's the, if you wind up with an angle in the first quadrant, if it terminates in the first quadrant, then the reference angle is theta itself, right? That's the angle between where it terminates and the x-axis. All right, last one here. We've got 6 pi over 7. And the troubling part here is we have no idea, or may have no idea where that falls, in what quadrant. So because it's 6 pi over 7, I know that that's really close to 7 pi over 7. It's just a little bit behind 7 pi over 7. And 7 pi over 7 is equal to pi itself. So it's a pretty good idea. It's going to be in this area somewhere in here. It's just short of 7 pi over 7, or pi itself. I'm pretty sure it's in the second quadrant. I know it is, but another way that you can tell what quadrant it's in is actually see what the decimal version of this is. So between 0 and pi over 2, that's everything in quadrant 1. And that's all I did here, is I just actually divided pi divided by 2, on the calculator. And if the value is between 0 and 1.57, that means that the angle is in quadrant 1. If the value is between 1.57 and 3.14, it's in quadrant 2, right? Because that's between pi over 2 and pi. So what we could do is we could do 6 pi over 7 and just see what the decimal form of that is. All right, 2.69, which is in between these two values. All right, so that makes it between, it's in quadrant 2. Right, that's another way that you could tell what quadrant you're in, so you could tell what formula to use. So we know we're in quadrant 2. All right, so quadrant 2, it's pi minus whatever the angle is. So we're going to be doing pi minus this angle here. All right, 6 pi over 7. Well, I want this to have a denominator of 7, so I'm going to multiply it by 7 over 7, which just becomes 7 pi over 7. And now we can subtract straight across here. 7 pi minus 6 pi is 1 pi, and still have a denominator of 7. So that's my reference angle, pi over 7. I hope you understood what I was doing here. Whatever the radian they give us over here, so let's say it was some weird radian like, I don't know, 21 pi over 43. Like, we have no idea what quadrant that's in. But we can just, type into our calculator, and that'll tell us, the decimal value for it. 21 pi over, is that 43? All right, because it gives us 1.53, which is between 0 and 1.57, I know that this radian here is going to be in quadrant 1. All right, so that would tell me which reference angle formula to apply. I hope that helps you a little bit.